In this video, we're going to discuss the solutions for the midterm exam on pre-calculus during fall semester 2018. The exam contains 2 parts on the following topics. Let's start from the first part. So in the first part, we need to answer to the following questions. The first question is, if you're given the triangle with the A side is 3 and B side is 4, what is going to be the sine of this angle? So the sine of this angle is going to be the opposite side, 3, divided to the long side C. So we can find this C using the Pythagorean Theorem. This is going to be the square root of 4 in a square plus 3 in a square. So basically the square of this side plus the square root of this side is going to give you the square of this side. It is going to be the square root of 16 plus 9, or simply square root of 25 or 5. So this is going to be 3 over 5. So please note that you need to write down your answer inside the box. So in the second problem, we need to find the equation, the slope of the lines through these 2 points. So we can find the slope of the lines through the 2 points using the formula. We need to subtract the y coordinates of the points and divide this to the difference of the x coordinates. It's going to be y2, this is y1. 2 minus 4 divided, this is x1, this is x2, or vice versa. It's going to be 3 minus 1. So this is going to be minus 2 divided to the 4, or simply minus 1 over 2. In the next problem, we need to find the x coordinate of the point with the angle theta of pi over 2 on the unit circle. Right? Okay. So basically we need to draw the unit circle. So pi over 6 is going to be roughly this angle. This is pi over 6. So if the y coordinate of this point is 1 over 2, what is going to be the x coordinate? So please note that on the unit circle, if you are given some point, any point here with the coordinates x and y, and if you draw kind of angle, let's say beta, the sine of this angle is going to give you the y coordinate of this point, and the cosine of this angle beta is going to give you the x coordinate of this point. So since I know that the sine, so let's calculate this. So sine of pi over 6, it's going to be 1 over 2, right? So in order to find the x coordinate of this point, I need to find the cosine of pi over 6. So the cosine of pi over 6 is going to give me the x coordinate of the points on the unit circle. So this is going to be square root of 3 over 2. Problem number 4 is we need to find out the center of a circle with the following equation. So let's do this. So in order to find this, we need to bring this equation to the form of x plus a in the square plus y plus b in the square is equal to the r in the square. So I see here that I got a term x squared and 8x. So I need to write this x squared plus 8x, right? So I can write down this 8x in the form of 4t multiplied to the 4x. So, and I have to add here 16 in order to make this as a square of something. So, and I'm going to regroup these terms, y squared minus 10y. So it's going to be y squared minus t multiplied to the 5y. So I need to add here plus 25 in order to make this square. Right, so this becomes a square. So please note that if you add the 16, you have to subtract the 16 as well. And if you add the 25, we have to subtract this 25 as well, right? And additionally, we've got one more term, which is plus 37, and it should be equal to the 0. So please note, if you add the 16 to the 25, you'll get minus 41. And if you add this to the plus 37, you will have minus 4. So if you put this minus 4 to the right-hand side part, we'll get the following equation. So I can write down this term now as the x plus 4 in the square, and we can write down this term as the y minus 5 in the square is equal to the 4. So looking to this equation, this term here is going to tell me the x-coordinate of the center of the circle, and this term is going to tell me the y-coordinate of the center of the circle. So the center of the circle is going to be at the point minus 4 and 5. And in the last equation, we need to find the magnitude of the vector. So if you're given the vector is a t-tuple, basically with the t-coordinates, the norm of this vector, which is the same as the length of this vector, is found out by squaring each of the component of the vector and adding them. So it is going to be square root of the square of the first component, square root of t minus 1 in the square, plus the square of the second component, square root of t plus 1 in the square. Then we have to take out we need to add them and take the square root from this. So let me find the square root of this. It's going to be t minus t square root of t plus 1 plus t square root of t plus 1. So we can cancel these t terms, and what is left is simply square root of 6. So I can write here square root of 6. Let's discuss the questions from the second part. In the first question, we need to sketch the graph of the exponential function 3x. So in order to sketch the graph, we need to find at least 3 points. So we know that the graph of the exponential function is always going through the 1, right? So let's make a table first of all. So this is going to be the values for the x, and I need to find the values of the f of x. So at the x is equal to the 0, I've got 1. At the x is equal to the 1, we will have 3 here. And when x is equal to the 2, it's going to be even higher, 9. When x is equal to the minus 1, we'll have 1 over 3. When it is minus 2, it is going to be 1 over 9. So I need to put this point. So whenever it is minus 1, it's going to be 1 over 3 and even 1 over 9 here. So the graph of this function is going to be like this. So this is the graph of the exponential function 3 in the power of x. So please note that in order to do this during the exam, you should find at least 3 points or indicate 3 points. So now we need to sketch the graph of this function, 3 in the power of x plus 3 plus 1. And in order to do this, I'm going to use this graph. So basically, we know that this plus 1 means that I need to put this graph 1 unit upper. And this plus 3 means that I need to move this graph to the 3 units lefter. So this will move the graph to the left 3 units. And plus 1 means that I need to move this graph to 1 unit upper. So it's going to be 1, 2, 3 units here. And 1 unit upper is going to be here, 1 unit upper. So again, our graph should cross the 1 as before, right? Then it is going to look like this. So very much similar to this graph, we just need to move this to some units left, in, up. Right? So this is going to be minus 3 and 2. So previously it was 0 and 1. So we move this 1 unit up, so it became 2. And we move this 3 units left, it became minus 3. Problem T, point T, we need to consider this function and try to sketch this graph. So if you're given a function in the form of a multiplied to the cosine of bx plus c, we can find the amplitude, the period, and the phase shift using these 3 constants a, b, and c. So the amplitude of this function is going to be the module of this a. So in our case, a is equal to the minus 2, so that is why the amplitude of this function is going to be module of a, or simply 2. Module means the absolute value of this a. which is 2. And the 2 pi divided to the b is going to give us the period of this function. So in our case, the b is equal to the 2. So that is why the period is going to be equal to the 2 pi divided to the 2, or simply pi. And in the last one, we need to use this tables in order to sketch the graph of this function. So we can do this using again the graph of the reference function, cosine of x. So first of all, we need to draw the cosine of x. So in order to do this, we need to put some points. So at the 0, it's 1. At the pi over 2, it's 0, then minus 1, then 0, then 1. And it is going to be symmetric to this part as well. So if I draw the cosines graph, it is going to be like this. So now if I just multiply the cosine of x to the minus 2, it will just go up 2 units. So so now the amplitude of this graph is 1. You see, so all the values of the function are between minus 1 and 1. So if I multiply this to the 2 or minus 2, so all the values of the function should be in between minus 2 and 2, but I need to flip this function as well because I'm multiplying this to a negative value, negative 2. So basically it's going to be here, minus 2, then 0, then 2, 0, minus 2, and it's going to be symmetric here. It's going to be 0, 2, 0, minus 2. So if I draw this, it will be roughly like this. So this is going to be the graph of the minus 2 cosine of x. So if I would like to draw this, if I would like to change the period of this function, so basically I multiply this to the 2, right? So the period is going to be smaller, and this graph is going to be 2 times like squeezed in the x direction. So it's going to be minus 2 here, and instead of 0 and a pi over 2, its period is going to be twice smaller, right? It's going to be 0 at the pi over 4, and 1 at the pi over 2, and 0 here, and at the pi I will reach 0 again. So it is going to be symmetric in this direction again. So the graph of this function is going to be very similar to this red one. So since I changed the period, it's going to be minus 2 cosine of 2x dx. So now this plus pi means that I need to shift this graph to the left, but not to the pi units. I have to shift this to the like a pi over 2 units. So basically the phase shift was like this constant c divided to the b was the minus is going to give you the phase shift. So this is how we need to move this. So we just need to take this graph and shift this to the left at the pi over 2 was the minus. So pi over 2 units in the left direction. So it is going to be here. Two. So if we draw this function, it's going to be roughly like this. And this black curve is going to be the graph of the minus 2 cosine of 2x plus pi. So we use the graph of the cosine of x in order to draw all of these graphs, just using the transformation of the functions. Problem 2.3 is we need to verify this graph. So we can start from the left and try to show that this is going to be the same as the right-hand side part. So the tangent square of x can be written as the sine of x underscore divided to the cosine of square of x divided to the secant is 1 over cosine. So if we give the common denominator, it's going to be 1 plus cosine of x divided to the cosine of x. So at the same time, so I can just cancel one of the terms here, And what we have here is going to be sine square of x. So this term here is going to be just go down here, and we can write this as 1 plus cosine of x multiplied to the cosine of x. So instead of multiplying this cosine to all of these terms, I would like to make this simply differently. So since I need to get here, I need to keep this cosine in order to get the right hand side part. So we know the trigonometric identity that sine square of x plus cosine square of x is equal to the 1. From here we can express that the sine of x in the square is 1 minus cosine of x in the square divided to the 1 plus cosine of x multiplied to the cosine of x. So at the same time we can write down this 1 minus cosine of x as a 1 minus cosine of x multiplied to the 1 plus cosine of x divided to the 1 plus cosine of x multiplied to the cosine of x, and we can cancel these two terms, and what is left here is 1 minus cosine of x divided to the cosine of x, which is the same as the right hand side part of the first equation. Problem 4 is about the composite functions. We need to evaluate the following composite function at some point. So we need to find h of 1. So h of 1, it's going to be f of g of inverse at the 1, right? So what does it mean? So what is the g inverse at the 1 is x. So let's assume that this is x, which I don't know, but at the same time I know that the g of x should be equal to the 1. Then I need to go through the values which are given. So at which value of the x, g of x is equal to the 1 is here, right? So at the g of minus 3, it is going to be equal to the 1. So that is why the g inverse at the 1 is going to be equal to the minus 3. So it appears this is the same as evaluating the f at the minus 3. So if I would like to evaluate the f at the minus 3, I need to go to the given values again. So f of minus 3 is going to be equal to the 5. So the answer for this problem is simply 5. Problem 2.5, it's about the inverse function. So we need to verify whether these two functions are the inverses. So we can do this by finding the composite of these two functions. The composite of the inverse function is going to be equal to the x. So let's calculate the composite function of the f of g of x. So basically, in the f, for all the appearances of the f, I need to put the g of x. Basically, it's going to be g of x in the cube minus 4. So now I need to substitute the g of x to here. It's going to be x plus 4 in the cubic root in the cube minus 4. If you open up the brackets, it's going to be x plus 4 minus 4 is equal to x. It means that these two functions are the inverses. So in this problem, we need to find the inverse of the function. So before we find, so we can find the domain of this function. So the domain is all possible values I can take for the x. So from here, I can see that the denominator x minus 3 can't be equal to the 0. So that is why x can't be equal to the 3, except this value, I can take any value. So the domain is going to be all the real values, right? Except this point 3. Or you can explain this from minus infinity to the 3 and from 3 to the infinity. So in order to find the range, we need to first of all try to find the inverse of this function. So it is clear for me that this function is 1-to-1 because this is very similar to the 1 over x. So 1 over x, the graph of the 1 over x would be like this, right? And 5 divided to the x minus 3 can be just obtained from this function, right? So I just need to move this function 3 units right, 3 units, and make this bigger 5 times, basically. But at the same time, it's still going to be a 1-to-1 function because of the vertical line test, right? So any because of the horizontal line test, sorry. So because any horizontal line is going to cross the graph of this function at most once. So it means that I can find the inverse of this function since this function is 1 to 1. So in this case, we showed that the function is 1 to 1 graphically. So if you would like to show that the function is not 1 to 1, you just need to give one counterexample. It will just prove that your function is not 1 to 1. In the last part, we need to find the inverse of this function. Y is equal to the 5 divided to the x minus 3. In order to find its inverse, I need to express the x in terms of the function of the y. So it's going to be y multiplied to the x minus 3 is equal to the 5. So x minus 3 is equal to the 5 divided to the y. So from here we obtain that the x is equal to the 5 divided to the y plus 3. And in the last, I need to change the x and y with their places. It's going to be y is equal to the 5 divided to the x plus 3. It's going to be the inverse of our given function. So the domain of this function is going to be the range of the original function. So domain of the inverse is the range of the original function. So the domain of this function is all possible values for the x except the 0. So x here on the denominator can be equal to the 0. So that is why the domain of the inverse of this function is going to be all possible values except the 0, right? So the domain and the range of the original function is going to be all values from minus infinity until 0 and from 0 to the infinity. So this is all the questions of the midterm exam.